sort of trying to catch up to you guys. So again, which way is this going to open? Is it going to open right, left, or up, down?
Right, left.
Right, left. It's going to be in the x-axis. That's the one that's positive, right? So the one thing I was going to do, I forgot I was going to put a negative on that. That's where you got to be really careful, because if you divide by negative 81, of course it flips which one's negative, which one's positive. So you just be careful.
In that case, it'd go up and down.
In that case, it would be up and down. Exactly. But the beautiful thing about it is, once you draw that box, you can do either way just as easy. You just have to identify at some point which way it's going to go. Of course, that's over 1, so then A is 1 and B is 3. And the only real reason we take a minute to square root those is because that, of course, tells me how far I'm going to go in each direction. Right? One thing I didn't do over there is, what's the foci? What's C going to be? C squared would equal
Root 2.
9 minus 1, 7, root 7.
That would be A squared plus B squared. So when you're dealing with hyperbolas, they have a minus here, so they have a plus there. Ellipses have a plus here, they would have a minus there. So that's the way to remember. So yeah, it would be a square root of 9 plus 1 square root of 10. Is that cool? Okay. And then when you go to graph this, along the x-axis, you're going to go out 1. And along the y-axis,
3 down.
3. So again, I'm going to have this fat hyperbola. So then you can draw in your rectangle. Hopefully you do a better job than that. Okay. And since your hyperbola, now 11.4 is going to be all about, what if I shift all of these? Right? So that's the one that's going to take a little bit of work to talk about the math that goes behind figuring out where things go. But here, I draw in my asymptotes. Just straight through the corners. Is that cool? That's all I'm doing, is going right through the corners of that rectangle. And we already established that it's opening on the x-axis. So it's going to be that fat. Wow. Monster fat. Well, hyperbola's doing what it can. Okay. If it went the other way, it would have been a lot skinnier along the y-axis, because those asymptotes would be a lot closer in. Yes?
Why did you find the slope on the other one?
I just wanted to show you what that meant, because you'll see that in the book. So if they asked me for the asymptote equations here, you've already drawn the lines. So then you just say, and they all go through the origin, which means every single b is going to be plus 0, right? So it really is just the slope x. So I just go, okay, up 3 over 1, plus or minus 3x. It's going to be 3x and negative 3x. That's my asymptotes. I always hated finding those first and then graphing them, when I can just graph the damn things and then look at it and get the equation. Much easier. Okay, yes, sir?
What was the point of the foci?
The foci are really just part, don't worry, they're part of the definition of it. So if what's the square root of 10 approximately?
3.2.
3.2. So along the axis here would be 1, 2, 3.2. So my foci would be there and there. So what's interesting is, if you push this foci, if you push it in, it actually makes it like that. I don't know if you guys are with me or not. So if you pull it out, it makes it flatten out. If you take it to infinity, it would just be a flat sheet. Kind of craziness, right? Yes, sir.
So the foci are always going to be on the axis to where the...
They always have to sit, and they always have to be inside the image. So in an ellipse, they're going to be inside the ellipse. Hyperbola, if I said inside a hyperbola, the only thing it could mean would be inside the curve. Do you see what I'm saying? So does that make sense if I say that? Sometimes it doesn't, because it's like outside. But the hyperbola actually has that inside.
Yeah, because all that's just imaginary.
Yeah, and the middle is all not really there. I like it. Cool, maybe. And if you do the math, that's where it's going to end up. So it wouldn't make any sense for the foci to be there and there, because they're not controlling anything. There isn't anything there to control. They got to control the shape of this thing, so it's got to be on that axis where that's sitting. Cool. So what we're going to do next time is I'm going to have a little group work that's going to incorporate some homework problems in it, so you get some homework done at the same time. It's always kind of nice. And just do several examples, progressively more ugly. And that'll be turned in for a group work grade. And then we'll just kind of get a little preview of 11.4. And then we got to do a review of the math that's required to do 11.4. So that's going to take a little bit of time. All right.